All right, so if we're going to put these in vertex form, that's kind of ideal because we have the vertex. So it says that the vertex is, I know it's hard to see, but this is at 9, 0, right? So if I have the vertex, okay, so I know this part. So y is equal to a, but I know what h and k are, right? So h is that, so it's if it's at 9, if x is at 9, we're going to say x minus h, so h is 9. And then k is just at 0, we don't need to put anything there. There's a couple ways that we could find out what the a value is. The first method would be that step method, where we could say, okay, so from this point, when I go over from the 9, I go over 1, I can see I'm going to go up 1 here, right? Because it went up to 10, 1. So if it goes over 1 and up 1, I know a is equal to 1. But I know a lot of people don't do that, and what they want to do is they can substitute any other point other than the vertex into the equation that they have and then solve for a. So let's just do that. Let's say we substitute 5, 16. Okay, so if we have a y value of 16, a times, okay, and then we're going to substitute 5 in for x, so 5 minus 9 squared, okay? So that is going to be, what's this? 5 minus 9 is negative 4. Negative 4 squared is 4. So this is just going to be 4a is equal to, oh, so squared. Sorry, so let's square that. 4 squared is 16. Let me fix that. Duh. So it's 16a is equal to 16. There we go. So a is equal to 1. Okay, likewise, if we substitute this value, we would get the same idea, or 10, 1. It doesn't really matter. Okay. All right, so we know, so now we can say that y is equal to just x minus 9 squared. Okay. The a value is 1. We don't need to put 1 right there. Similarly, let's look at this question over here. And both of these are kind of special cases because this has one root. Okay, it has one root. It doesn't have, and the vertex is on the axis of symmetry. That's a case there. And here's a case where we only have the vertex is actually on the y-axis. Okay, so what does that look like? Well, again, so this is the vertex here, so it's at 0 for the x value, so h is 0, and then k is at negative 10. Okay, but what is our a value? This might be a little bit different this time, because if we're going 2 units over, we go up, how many? 4. Okay, so normally when we square 2, 2 squared is 4, so I think that still has an a value of 1, but let's just substitute one of these other values in there. It doesn't really matter, we'll pick that one. So right now we know that y is equal to a times x minus 0, that's just x, squared, and then k is minus 10, right? So if I substitute, let's say we're going to substitute 6 here, and we're going to substitute negative 4 in there. So 6 is equal to a times, and this is going to be what? 4 squared, negative 4 squared is 16. Okay. What did I put? Minus 10. Okay, so then what we have is we're going to have to add 10 to that side. So we'll have 16, oops, my pen, is equal to 16a. So a again is equal to 1. So we just have y is equal to x squared minus 10. So these are both special cases because in this case the h value is 0, so we don't actually have that bracket there. And in here k is 0, so we don't see k.